Okay, if you are looking at my screen, you will see I have a different score here. Don't panic. The reason why is because my time actually ran out, and so I had to reset everything. And so when I reset everything, you can, let me show you where it actually changes. It's right here, the train test split. And so this is a reason why people oftenly put in the random state. Now, I'm not going to do that here because I think it's kind of cool when you get different splits. Um, and like I end up with different scores, right? It's not as strong of a, I think, starting score. And I just ran all the code. And when you do that, you may see, well, look, the best in estimators may be something different actually. Here it was 200. And, but I just ran everything that I had and did start to get good scores based on previous results. So this last coding cell run is based on the previous fine tuning where reg lambda is set for 6, etc. And so the next question would be, okay, it's a different split. What about from here? What can I do, like if this is my starting point to kind of see, you know, like can I make it better? Well, this is where randomized search CV can be really nice because we can use everything within close range. Like for instance, if we're splitting the difference 2, 3, 4, and estimators, maybe go down, you saw before 200 was a good one, so maybe start there. 200 to, I don't know, 250, 325, 375. Okay, some kind of a split like that. Can we put 400? And, so let's keep adding different possibilities. Now, this is already quickly becoming unwieldy to do by grid search, and so we can use the randomized search. Okay, that's the idea. We're going to look at random combinations of these different values. Oh, excuse me. Okay, and, like, it's worth throwing in some extras. I don't want to give too many extras for ones that, like, they weren't tuned, right? So the idea here is that gamma wasn't tuned, so I don't want to put in necessarily extra values for gamma. Resman child weight was tuned, so it's worth putting in maybe a few more, right? And same with reg lambda. Okay, so we're seeing now. Don't just run this. Okay, what you want to do is you want to run this on a how would I put it? The random equal to true. That way it only run 15 random combinations. If you ran all of them, it's just the multiple of the number. So like 3 times 4 is 12, times 3 is 36, times 3 is, what's that, 108, times 2 is like, it's over 200, 400, 800, times 3, 2,500, 7,500 different XG boost models, and with an average of like a couple hundred. I always like to see, it's kind of fun, right? With an average of a couple hundred, 7,500. These are just estimates. The average more like 300 trees each. And so when we multiply those together, we're looking at basically 2,250,000 decision trees. And you know what? You could totally do that here because there are only so many rows. But if you had like a ton of rows, it wouldn't work. So let's try this randomized search and see if it'll get better than the 613.79. Okay. It did. It got 606.19. Right. And, it's always worth looking, I think, what values worked better and then potentially using that as a new starting place. See, so if I copy this and then I bring it down here, now this is interesting. Max depth has gone up. Gamma has gone up. Wow, see, you could almost start here and continue like to tune it. Fine tuning, I like to spend a lot of time on it because you never know like what's going to work and that type of thing. Meaning, if this is kind of like a new starting place, it's based on a slightly different split. Can I find more kind of leverage with gamma? Do I just do it again, but do it a little tighter, right? Do I Sometimes also you can hold things and, hold things and change other things. What I mean is you can just put in each of these individually. Now the call sample thing is really interesting, that the one, see, subsample, I think we just don't want to change, whereas call sample by tree did go down. So that's really interesting, I think. Call sample by node stayed the same. Call sample by level may have gone down slightly. Okay, and yeah, why don't I just start? Well, I'm going to take these one at a time, okay? I'm just going to do a little bit more with this to show you my approach. Min-child weight also changed. So, yeah, I think what I'm going to do is, how many is this? Well, you know what? If you do random equals true, you don't really have to worry about it. It's going to like, it's going to check. Maybe I'll leave reglamp also at a 6. It's good. Let's just do random again here. But what I'm doing is I'm narrowing the range. Now with all these in estimators, what did I get? 250. In estimators can make a big difference, so I actually want to leave that. Okay, let's just try this. And again, you set that random, it's only going to do 15 builds, so it's only going to take so long. We're seeing, can we improve that 606.19? And look at that! Did it, got under the 600. So, I could keep going or I could rest on that, right? And you can see that, before it's not checking every sample, so this is not a thorough search. When I narrow the range, it's checking more of the possibilities. So if I do want to check now for potential final improvements, I can say, well, interesting, max depth went up, and estimators went up. We're going to keep the reg lambda at 6. I'm going to keep the min-child weight at 3. Now, gamma went back down. Gamma keeps changing, so I'm going to leave that as a change option. 3 times 3 is 9 times 2 is 18. I want to try this as is. Okay? And note that some of the defaults are changing, by the way. Oh, by the way, I'm going to take out random equals true. So now I'm forcing a check of all these combos. And again, you can keep going with it and keep going on it. Okay? I'm not going to do it really, I think, beyond this one because, right, you get the idea. The point is that can you watch me improve it? The point is, what ideas do you have? What can you do to improve it? I did see a slight improvement. Let's see what changed. What did change? The call samples cannot have changed there. Gamma, max, depth, min-child weight, in estimators. Okay, interesting. And it's about the same. So this is not, so let's say that this is the final model. Okay, so how do I do that? All right. I want to say final model equals XGB regressor. And then don't forget that objective. This is kind of the objective thing. I wish they would just fix it soon. What is it? Objective. You know what? If I type in the model, I think it shows it to me. So we have a default model. See, we haven't updated the model. We're just testing it. There it is. Objective equals reg squared air. And now we put in everything. Okay, we put in all the values. They're all here. Now, some of these we don't need in here because they are the defaults. And, I like fixing it up. Like, sometimes when you copy and paste, it doesn't look nice. But it is nice to have one on in each row, you could say, for readability. Okay. And so these are basically what we've tuned. Okay. And again, it's kind of cool to leave the ones up because we actually tuned them. We just got the same defaults for XGB. Okay, so this would be the final model. And now what we're going to do, okay, is we are going to see if you run it, right, it doesn't do anything. Oh, got an error, invalid syntax. What did I do wrong? Oh, these need to be equals. This is like dictionary syntax. So it's dictionary syntax versus, you could say model, parameters, right? Because when you're inside of a function, you know, you're setting things equal. We're setting these parameters equal to these values. Oh, and the other thing is the quotes. Sorry. Quotes are no longer there. So the syntax does change. It's a little tedious, but you want to get it right. And I think what you find in every pursuit, like professions, line of study, there are always like little, you know, things that might be tedious or that you don't like to do. That's just part of it. You know, nothing's ever going to be perfect, right? Okay, so what we're going to do after making these corrections, we're going to change it or train it. Now we're going to test it. Okay, we haven't tested it yet. We've been sort of testing it using the cross validation, but the big question is how will it do in the data it hasn't seen. That's what we're going to find out. Okay, and I'm going to make that its own kind of should I make it its own header? Yes, I think so. I do like to be consistent too in terms of, you know, when you're doing a project, if you're doing spacing or not after an equal sign, be consistent. It just looks so much better. It makes your code so much more readable. And then so I'm going to write set final model based on best parameters. Okay, let's try to run it now. Good. No, it hasn't been, it's just there. It hasn't done anything. If you type it, we just see the values that we've tuned. So kind of cool, right? So now what we're going to do, last piece here, we are going to set model, well, test model. Okay, let's do it. All right, so we're going to use X test. So we've already defined final model. So we're going to do final model dot fit. Right, because see right now, wait a minute. Sorry, I had to think about this. It's been a while since I've done it right top to bottom. We have to fit the model on the data. So what we need to fit it on is the training data. Okay. I think technically this should go down here. So what we're basically doing, we're testing the final model. Okay, set final model based on best parameters, and then fit final model to the training data, right? We basically see it hasn't been fit, and the reason why is because the grid source is just doing all these tests, right? And like these mini tests to see, well, how good are the parameters? Now we're going to fit it with those parameters. Fit final model to training data using best parameters. I'm going to add that in for emphasis, okay? All right, and it shows us them, but at the point in now it's been fit to the data, so it's a little different. Okay, now we score final model on test set. Now's the big catch. Okay, so what we need to do here is we're going to need to from sklearn.metrics, we're going to import the, I think it's the mean squared error, negative mean squared error, better. And that's what we're going to use, okay? So we're going to compare the predictions on the test set. Okay, you ready? So it's final model dot predict. And we're going to make predictions from the test set. See, this model's never seen this, okay? So new data is coming in here. We haven't used it at all, actually. And now we get the predictions from them. And so what we can do now is we can get we want to compare now. It's been a while since I've done this. So basically, let's just say that MSE, the mean squared error, is the negative of the negative mean squared error on the, we're comparing, see the Y. Gosh, sometimes I forget what comes first here. Is it Y? I just don't have it right in my mind. Well, let's say it's Y test and Y prediction. We can always check it. And then flip it to see if it matters. Right, so that's going to give us the mean squared error, but then we want the root mean squared error. So the RMSE is simply the, yeah, well, let's just do it like this to make it more clear. It's the negative of the MSE to the 0.5 power. That's what we want to print out. Oh man, how do I, I could just look it up, but let's just run it and see. So we're expecting something close to like 600. Okay, got an error. Cannot import negative mean squared error. So I called it something wrong. I think it's just because it's just mean squared error. It showed negative mean squared error as an option. Oh, or did I write it because I wrote the same thing? Wait, let's just try it like this. NaN didn't work. Oh no, running into final issues down to the wire. I don't think this is the issue, by the way. Shoot, NaN is an issue. I can tell you another way I can try to run this is if we do final, let's do a check here, final model.score. This will give the R squared, and we can try to run the scoring and see how does it score X test and Y test. %. Wow, that's really good. Wow. So 91% of the data is being accounted for. And if you want to compare that, right, like how did it do on the training set? Well, 99, right? It did it much better because it was fit to that. So it's still overfit, and that's valuable information. But I want to get it right for you with the mean squared error. So we train, let me double check this. So we train the model in the training set. We get the prediction on the test set. And then you typically do run like a score. And I can just put in here. Let's try mean squared error, sklearn. Y true and Y prediction. So Y prediction is supposed to come second. So sometimes when you see but there shouldn't have been any null values. I was going to say sometimes when you see, and it worked here. Let's double check. Oh, is it because it doesn't need to be negative? Maybe that's the issue. Okay, I think that'll fix it. Yeah, there you go. So look at that. It actually scored better. That's awesome. Okay. So yes, yeah. So the import, like it wasn't the negative. Note that there can be some confusion here because when we're doing the grid search, like it is negative. Okay, just to show you. Right, it has to do with different scoring metrics in different places. See, scoring equals negative mean squared error. All right. So we didn't really use the R2. R2 is like how much of the data it's accounted for. So this is good. We can conclude then that wow, this is great. So I'll just give you guys my concluding comments on this. They would be the following. So the model accounts for 91% of the data, more or less. That's a loose way to interpret R squared. Let's say with an RMSE of 572.4, indicating that the model generalizes very well. Okay? Nice job.